Good morning, my name is Jozef Aerts, well known to many of you. This time I will inform you about the progress we made in the last year in the HL7 Vulcan project, a project also supported by CDISC. I am however participating in this project on behalf of youth. I must emphasize that all in this presentation is my personal opinion, and not necessarily the opinion of CDISC, HL7, FHIR or anyone else. The major part of my presentation will be about automated generation of SDTM datasets directly from electronic health record systems using the FHIR API. As this, due to the discrepancies between terminologies used in healthcare and clinical research, requires a lot of semantic mappings, I will also provide you with my thoughts on mappings. And finally, I will report about the progress FHIR is making in coming to a real electronic protocol, an area in which we, within CDISC, have made little progress in the last 10 years. Let's start with an overview of the Vulcan project. The HL7 Vulcan project aims to close the gap between clinical research and clinical care. There are a lot of stakeholders and paying or non-paying members, including CDISC. Here is a list of the members involved in the Vulcan project, also available on the project's website. The project consists of a number of sub-projects with their project teams: real-world data, schedule of activities, FHIR packets, electronic product information, adverse events, and FHIR to OMAP. I am mostly involved in real-world data and a bit in schedule of activities. The real-world data team is led by Scott Gordon of the FDA and concentrates on the automated generation of SDTM datasets with embedded source EHR records using FHIR and its API. In order to achieve this, there is a strong cooperation with the Schedule of Activities team, which is currently doing fantastic work. During the last HL7 Connectathon, we have been able to demonstrate the fully automated generation of SDTM datasets for demographics, concomitant medications, medical history, adverse events, and a number of findings domains such as laboratory, microbiology, vital signs, and some of ECG. And of course also the generation of corresponding supplemental qualifier and related records datasets. All this starts from the relative new FHIR resources research study and research subject, defining the subjects enrolled in the study, or from a SNOMED CT code for the specific disease. All the code developed for this project is available as open source. It uses the by CDISC published mappings between FHIR resources and CDISC domains that were developed by Lloyd Mackenzie on behalf of CDISC. As we wanted to demonstrate traceability by embedding the source EHR records into the SDTM records, we could not use the outdated SAS transport format, but selected to work with CDISC's own modern dataset XML format. Currently, we are also adding support for the new CDISC dataset JSON format, a format we think the FDA cannot deny. For the HL7 Connectathon, we decided to reverse engineer the well-known LZZT SDTM datasets to FHIR resources, also in order to be able to demonstrate the usage of the newer FHIR research study and research subject resources. This reverse engineering step proved to be more straightforward than expected. As almost all electronic health record systems use LOINC coding for tests, but CDISC still sticks to its own post-coordinated control terminology, we used a considerably extended version of the LOINC CDISC mapping, which has been implemented as a RESTful web service that is free for everyone to use. We then generated the SDTM datasets in modern dataset XML format using the already mentioned open source software, which is very generic. We also demonstrated the methodology for other sets of data at different conferences. For example, for the cases of diabetes, COVID-19 and Alzheimer's disease. Because of the time limits, I will not demonstrate the use of the software here. You can find a good number of movies about it on the internet. What you see here is a snapshot of the visualization of the results using the Smart Submission Dataset Viewer. Using public RESTful web services, the viewer allows to provide all necessary information about each line code. Essentially, there is no need for test CD, test, spec, and so on anymore. The viewer also allows to inspect the source EHR record of each SDTM record, enormously increasing traceability. The reason this is possible is that we do not use SAS Transport 5 format, but modern CDISC dataset XML format. This allows to embed the EHR source record into each of the SDTM records. With SAS Transport, this is impossible. Another way is to keep a reference to the source EHR record in the reference ID SDTM variable. Just a click would then enable the reviewer to see the source record. This of course requires access to the record or a copy of it on a FHIR server. Remark that we also kept the usual UCOM notation for units of measure. This enables the automation of unit conversions, even between conventional and SI units, which is not possible when using CDISC units. Here a short demo of what is all possible using RESTful web services when the source EHR record is embedded into the SDTM record. We also see here that using the LOINC CDISC mapping, a number of non-standard variables has become necessary. Essentially, however, the LOINC code alone is a much better designator for the test than any combination of post-coordinated SDTM variables. As one should already have noticed, we use a lot of RESTful web services. This is very easy when using dataset XML or dataset JSON, considerably more difficult when using SAS Transport. Whereas the software for generating the SDTM datasets already uses the FHIR API and a few others, additional RESTful web services are used by the Smart Submission Dataset Viewer, including the CDISC Library API, LOINC and National Library of Medicine APIs. The use of such allows to make the review extremely user-friendly. And very soon we will also be able to implement the CDISC Open Rules API. Unfortunately, SDTM has been trying to achieve more reviewer friendliness by adding an ever-growing set of new but essentially redundant variables. This makes generation of SDTM datasets extremely error-prone. Use of RESTful web services instead of adding more variables is the much better way to go. As SDTM uses post-coordinated controlled terminology, we had to do a lot of semantic mapping. Let me share my thoughts on mappings. During our work, we soon found out that the by CDISC published LOINC SDTM mapping is completely insufficient for real-world work. It only covers a small part of the LOINC codes used in real-world labs. It does not cover any microbiology, almost no challenge tests, and a very limited amount of drug toxicology tests. It does also not cover any tests that map to other than the LB domain, such as microbiology, vital signs, ECG, questionnaires, and so on. So we had to considerably extend the existing mappings. We extended the LOINC LB mapping from about 1400 LOINC codes to almost 10,000 LOINC codes with over 18,000 mappings. We developed mappings for over 100 LOINC codes for COVID-19 tests and mappings for over 500 vital signs test codes. One can already guess that this was a huge effort, which is still ongoing. So you can easily think, has Jozef lost his mind? And maybe you are right. Especially as mapping is always bad and dangerous, but with the SDTM as it is now, there is no other way. Why is mapping so bad? Well, it almost always leads to information loss. Mappers, like me, need to learn and understand two different coding systems. The implementation is very prone to error. Maintenance of the mappings is a nightmare. And, more fundamental, mapping consolidates the not invented here mentality. So, how can we do better? Topic variables in findings domains are of type required in SDTM and thus must be populated. Given that a LOINC code is a much better designator of the test, better than any combination of SDTM variables, it should be questioned whether this makes sense. Thus, if we get a LOINC code from the lab or from the EHR, why do we still need to provide test CD, test, spec, and so on? Key here is reviewer friendliness. This can, however, much better and without errors be provided by use of RESTful web services rather than relying on mappings. So, when one does have the pre-coordinated code, there should be no need at all anymore to perform mappings. First of all, we must learn to achieve reviewer friendliness by software and APIs, instead of adding new variables to SDTM over and over again. This also means that we must make variables like testcd and test and some others optional when the LOINC code is provided. These variables do not bring any additional value, and mapping to them is error-prone. Back to the Vulcan project. What we see is that FHIR has been pretty successful in making steps to come to a real electronic protocol, whereas we in CDISC made little progress in the last 10 years. With ODM version 2, however, we get a new opportunity, also by using a lot of the IDs from FHIR. On this slide you also see a list of newer FHIR resources that can in future lead to a completely machine-readable protocol. A few conclusions. SDTM datasets can easily be generated from EHRs using FHIR. The major limitation is that for findings datasets we need mappings from LOINC, but sometimes also from, for example, SNOMED to SDTM control terminology. Mapping is however bad and should be avoided whenever possible. So, when the LOINC code is provided, it should not be required to populate SDTM variables such as testcd, test, spec, and method. Thank you.